right? For this question, a layer of mercury traps a volume of gas in a tube. The tube is placed in a water bath and slowly heated. When the temperature of the water is 300 Kelvin, the height of gas H in the tube is 150 mm. What is H when the temperature of the water is 360 Kelvin? All right, so there are several variables in this problem. Okay, one is we have information on volume, or it's telling us about volume. We also have information about temperature, okay, and then you also have information on the height, okay, that this mercury takes over time. Okay, so how will we go about a problem like this? Okay, well, first things first, initially, okay, what are our initial conditions? Initially, the temperature of water is 300 Kelvin. Okay, so I'll just write that somewhere. Take note of that. Initially, it's 300 Kelvin, and when it is at 300 Kelvin, the height is 150. So this H that you see here, this is when your temperature is 300 Kelvin. Okay, you want to figure out what will your height be, okay, your new height, when your temperature increases. So this is going to increase, and eventually it will become 360 Kelvin. All right, so that's actually kind of shown by the shaded part here. All right, or you can just kind of extend H. All right, whatever that new height is going to be. All right, as this fluid, or as this layer of mercury goes higher, right, or decreases. Okay, what will that be when your temperature is now 360 degrees? Okay, well, to start off with a problem like this, because we have volume, all right, and temperature, it's kind of like, you know, finding a relationship. If for volume 1 you have a certain temperature, okay, what would that temperature be for volume number 2? Okay, now you might be wondering, why am I equating these two? Am I not concerned with H? Yes, however, do recall that the formula for volume is actually just the area times the height of what you have. In this situation, I have a tube. We can take the cross section, okay, to be a circle. That is how you would get the area of the cross section here. All right, this here would be your area. So instead of writing it in terms of volume, I could actually just write it in terms of area times height, because I have information on height. I also could, you know, represent this setup with a certain cross-sectional area, A. Okay, so now that I have this, I can replace my V's with the following. And so my new expression is now going to be the area times the first height over the area times the second height, okay, equals temperature 1 over temperature 2. All right, do I have information on these things? Yes. Okay, in fact, for this one, first of all, my areas will cancel. All right, and then I can start substituting values. Okay, so this is going to be H1 over H2 equals my temperature 1, which is 300 Kelvin, over my temperature 2, which is, according to this, 360 Kelvin. Okay, and then because again I am interested in height 2, or this one at the bottom, I would flip things around. Okay, so this should give me 360 over 300 times H1, okay, equals H2. Okay, and I can simplify this. All right, 360 over 300, 36 over 30, that should give me 6 over 5 times that first H, equals my H over 2. Okay, but what is H1? We are told that H, the initial height, is 150. So all I need to do is do 6 over 5 multiplied by 150. And this should be 30 times 6. That will be 180 mm. Okay. So that would be my new height. If you look at the choices, that would be letter B. Okay, so the answer to this question is letter B, which is 180 mm. Right? So sometimes it may look a little overwhelming because you might not know how to begin, but just always list down the information you have, all right, and try to go back to the basics, okay? Relating one in terms of other variables, okay, in order to work with what is provided to you, all right?